This is the last question on the relation between Young's modulus, bulk modulus, and modulus of rigidity. Uh, let's say what this question is saying. A bar of cross section 8 mm by 8 mm is subjected to the axial pull of 10 kN. The lateral dimension of the bar is reduced by 2 into 10 raised to minus 3 mm. Find the Poisson ratio and modulus of elasticity. The modulus of rigidity is given, which is 80 gigapascal. Now write the given things first. Uh, the cross section area of this bar is 8 into 8, which is 64 mm square. It is subjected to the axial pull of 10 kilonewton. So the P is equal to 10 into 10 raised to 3 Newton. The lateral dimension of the bar is reduced by 2 into 10 raised to minus 3. Delta L is equal to 2 into 10 raised to minus 3. Find the Poisson ratio modulus of elasticity. The formula of Poisson ratio is change. Uh, Formula of Poisson ratio is lateral strain upon linear strain. So we have to find lateral strain and this strain to find Poisson ratio. So now using the formula of lateral strain is equal to change in lateral dimension upon original dimension. So change in lateral dimension is 2 into 10 raised to minus 3 and original dimension is 8. So the lateral dimension in any bar is width, or if it is circular, it is lateral dimension is taken as diameter. So here the bar is not circular, so the lateral dimension is the width of the bar. So width of the bar is 8 mm, so length is 8 mm and change in the lateral dimension is 2 into 10 raised to minus 3. So the lateral strain is equal to 0.25 into 10 raised to minus 3. This is lateral strain. Now we put the value here, and E is equal to, this E will go here and mu is here, mu EL is equal to 0.25 into 10 raised to minus 3. Now the formula of the Young's modulus is stress upon strain. We can calculate stress by the given information. Stress is equal to P upon A. P is 10 into 10 raised to 3 Newton upon area. Area is 64 mm square. So the stress is equal to 156.25 Newton per mm square. So now putting the value of stress in this formula and putting the value of E in this formula also, 0.25 into 10 raised to minus 3. This mu from the denominator is multiplied by this, because denominator denominator multiplied by the whole term, so it will go up and multiply by this whole term. Okay, now we calculate this value. E is equal to, we put this in calci and calculate this term, which is 625,000 mu. This is our first equation. Now we have to calculate the Young's modulus. So Young's modulus is equal to 2g into 1 plus mu. Now we know g, we don't know mu, and this E is in the form of mu. So put this 625 0.000 is equal to 2. G is 80 into 10 raised to 3 and 1 plus mu. Now the mu, here the value of E is put. So the one unknown, by calculating this in our calci, we get the value of mu which equal to 0.344. Okay, by multiplying this into this value we get the Young's modulus. Young's modulus is equal to 215,000 Newton per mm square. Simply put this value here on the space of mu and we get the value of Young's modulus. Firstly, identify the problem, what problem is asking about, and what problem is given. Here the lateral dimension change is given, so we calculate the lateral strain, and normal strain is not calculated, so lateral strain is calculated and put it into the Young's modulus form. We take a whole Young's modulus equation in the form of mu. So here one unknown remains only. We don't know E, so we have to convert this into mu, because here is unknown is mu. Two unknowns we can solve easily in calci. When we put this as x and this as x and put value of modulus of rigidity and these terms, we will get the value of mu which is 0.344. By multiplying this in this, we get the value of Young's modulus which is 215,000 Newton per mm square.